All right, check 1, 2. This is the 5-5 retrieval and ready and some set and some go. Hope you're doing well. I haven't recorded a video like all year, it felt like, but thanks to those that have checked these, and hopefully you get something out of this. Retrieval for 5-5 integrated 3 has this triangle, solving problems below, rounding answer to the 100th place. They give you that CBA, so starting at C to B to A. They give you that this is 42 degrees. They give you that CDA is 35. And they give you that AC, not to be confused with Atlantic City, is 22 inches. Although it's not asked of you, I think it helps to sometimes just separate the triangle from all the chaos that's happening in the world, where you might throw out this smaller triangle here, the site of 22 inches, and then also that second triangle. These are never drawn to scale because who draws to scale? And that definitely has this right angle at CAD. This is still 22 inches. This is where C was. This is A. This is 35. And naturally, that's angle D. So, variety of things you could say, start with. I'm curious which one you would start with, but I think that the easiest thing to do is probably get a hold of this angle here, because don't you already have 90 degrees accounted for here, and 35 degrees accounted for here? And shouldn't it just be the difference of 180 and the sum of these two? What do you think? So what's that? 180, and we're subtracting 125. So that means that this is 55 degrees. Nice cool day for angle ACD, which we actually are asked. So that's cool. So we got that one. We are also asked to get a hold of BCA, although it's not written here on this side. If this line cuts straight through and BAD is a flat line that's running perpendicular to CA, we can assume that this is a right angle. And that can then help us get a hold of angle ACB or BCA, a variety of ways you could describe these angles. So what do you think this angle BCA is going to be? Hopefully you're saying, let me get this math right, 48 degrees. Because if you add this with this, that's close, right? But psych. No, that's right. 48 degrees. Because 42 and the 48 give you 90, and then that also works with this 90. So boom, there you go. BCA is 48 degrees. Capiche capoche. Then BCD, what can you say about it? Well, that is the sum of this and this, where we said this was 48 and that this was 55. I guess we could have also gotten a hold of this if we did 180 minus 42 minus 35. Another approach. Or in this case, you can just add together the 48 and the 55. What does that get you? 103. 103 degrees. There you go. BC and CD, let's find those next. So we know that we have this height of CA, that's 22. If you were with us for the classwork, we said that the only way we can really use trig is if we know an angle that's not the right angle and some side. So that's an approach. Pythagorean theorem's kind of out the door right now because you only have one side. So I'm going to go out and get a hold of BC. How am I going to do that? There are a variety of ways you could do it. I think personally, taking cosine, is cosine the best way? No, variety of ways. Let's just stick with sine. So that's sine of 42 degrees, which I'm getting from here. What should that be equal to? 22 over BC, right? And then I think people get rather confused at this moment where you're like trying to break down the fraction. But if you multiply everything in here by BC, that cancels. That is then saying that BC is times sine of 42 should be equal to 22, right? So then how can you isolate BC? You would divide by sine of 42, right? So segment BC should be 22 over sine of 42. Hopefully your calculator is in degrees. You can take it from there. CD is going to be a similar situation where same song and dance. You could pick sine or pick cosine. I'm going to say that to get a hold of CD, sine of 35 should be equal to 22 over CD, right? And it's going to be similar algebra to this, but too long didn't read. You multiply by CD, but then eventually divide by sine of 35. So this is what sine of, or this is what CD would be equal to. And I'll leave it to you to get a hold of that numerically. C, I'll leave that to you. Will it be longer or shorter? What do you think? Take a moment to think about that. So hopefully you were saying that BD would be shorter than the sum of BC and CD. Reason being, if it was longer, BC and CD would not connect. Meaning that they wouldn't meet at that top point. Hope that helps. A little bit of a throwback with quadratics here. Definitely a quadratic. Although you don't see two roots, you got two imaginary roots on this. Write the equation. You know you have a vertex here at 3, 1, so it's definitely going to have this framing. X minus 3 being squared plus 1. I see that it's no longer an over 1, up 1. So you may want to dig in, solve for A here. You can pick any point, except not the vertex. So what am I going to do? I'm going to say that if X is 5, Y should be 3, right? So I'm going to plug in where X is 5. Why am I doing this? Because there's probably a scale factor here, and I just want to make sure that I get it right. So notice how I put X in as 5. Notice where I'm putting 3 in for Y. So there you go. 5 minus 3 is 2. 2 squared plus 1 equals 3. 4A plus 1 equals 3. 4A equals 2. This means that A is 1/2. So why does that help? Because when you summarize this final equation here, you're better off saying that it's scaled by 1/2 in vertex form like this. And they say make it a function, so I'm going to make it y equals pish kaposh. A little bit of integrated 2 throwback for you. Hope that wasn't too crazy. We'll see you in the ready. So you already kind of did something like this in the retrieval. If you've been watching this whole thing, you were given this setup and you're given a little bit about it. So this is 51. This is CDA. This is 30. Don't know why they give you this, but okay, thanks for stating what's already given, that this is 90. And I guess you could follow that up and say this is also 90, and this is 6. Okay, so what can be said? I didn't approach this one last time, but now I kind of want to entertain it because you have this for angle B, right? And you're asked BCD, so that's this whole entire part here. And you know this is 30. So shouldn't this also have 180 degrees total? And then you can get a hold of angle BCD if you just deduct 51 and 30. What are your thoughts on that? Getting you 99. Oh, I really hope this arithmetic is right. If it's not, let me know, but I'm pretty sure it is. BC, a variety of ways you could do that. We'll do that next, but BCA, let's break that down. This already has a 90 and a 50, so that's 141, and you're aiming for 180, so that's 39 degrees. And then that means that this would have to be 60 naturally because you already did that 5-5 classwork, right? And you already learned about this 30, 60, 90 setup. I can kind of speed run through this and list a bunch of stuff, which I'm actually going to do now. So if this is 6 feet, this is across from 30. If you did the classwork, you would know that the hypotenuse is double that. So this is doubled that 6, getting you 12 feet. If you also recall the classwork across from the 60-degree angle, that's the medium side, which is just smallest side times √3. Not to be confused with √2. Beach Kaposh. I know I'm kind of avoiding the questions here, but in a way I'm answering them. So deal with it. You'd be all right. What else do I need to say? BCA is 39, ACD is 60. BC you can get a hold of with trig, variety of ways you could do that. I'm gonna just follow through with the sine of 51 and how that should equal 6 over BC. You did something like this in the retrieval, which should eventually say that 6 over sine of 51 is equivalent to BC. So I'll leave you to get a hold of that in your calculator. BA at that point, you could do Pythagorean theorem to go about it, but I guess if you didn't want to, what could you do? I mean, you can get a hold of this, and that's going to give you your hypotenuse. Then you can do Pythagorean theorem, or you could take the trig approach, which I think is in your wheelhouse if you were with it for integrated 2. So again, variety of ways you could do this. So let me think. You know what? I'm going to do tangent of 39. That top angle, because that's the opposite over the adjacent. So that's BA over 6. And then this is pretty simple, just to multiply everything by 6. Getting that 6 tangent of 39 should equal BA. It's probably some of the quickest algebra you can do to get a hold of that. CD we said was 12 feet. AD, looking back, we said was 6√3. Again, if those don't make sense, look back at the classwork, look back at the takeaways. B to D, oh, big summary. Well, A to D, we know that's 6√3. And we know that B to A, we solved for that and said it was 6 tangent 39, right? So just add the two. And naturally, make sure your calculator is in degrees. So whatever this is, I'll leave that to you to add up. Area BCD. Well, you know you have your height of 6. So naturally, still doing 1/2 base times height. This is actually the whole base, is it not? That's the part that's just kind of lying here. And that was the 6√3 plus this tangent, 6 tan of 39. So that can be your base, and then your height is just 6. So just plug and chug for that. I'll leave that to you. Moving on, the set really hits home on the 30, 60, 90 ideas that were at play in the classwork. So to me, when I look at this, I know it's some kind of triangle, but what kind of triangle do you think it is? Hopefully you said it was an isosceles, where this is also 6 inches, or maybe you said it was 45, 45, 90. Find missing side and angle measures. Again, this is 45, 45, 90. So the hypotenuse is just this times √2. Naturally, keep the units there as well. Pretty light. 30, 60, 90. This is supposed to be 2 versions of the small side. So the small side recalls across from the smallest angle. So shouldn't this now be 4 feet? And this should be 4 √3. And this should be 60 degrees. Naturally, 4 √3 feet. Don't penalize me yet. What else you got? This is 30. This is the smallest side, so that's light work. 13 times 2, giving you 26 centimeters for the hypotenuse. This is 13 √3 centimeters, because you just multiply by √3. That's light. Across from 90 in a 30, 60, 90. This is double the smallest side, so that means this is 11 centimeters. This is 11 √3 centimeters. You see where I'm going with this? This is 1 centimeter because it's another leg. This is just saying that these are congruent sides. And the reason we say congruent, not equal, is because that's like saying it's in the same position geographically, and that's just not the case. So then I don't even, at this point, these are like all just kind of the same problem. And yeah, I guess if you want me to fill this angle in, I can. Last one. Oh, I like these ones. So think of that reverse trajectory from what you did back here. Didn't you just take these legs and multiply it by √2 to go to this? So isn't this just the smallest side times √2? And then how can you isolate the small? Hopefully you're saying divide by √2. So this can leave like that. And I say you could leave like that. I don't know how math person you want to get with this, but depending on who you ask, this has room to improve for the final answer. So if you want to rationalize the denominator, what you're doing is pretty much saying, hey, I don't really want to divide by this square root of 2. So you're going to multiply the top and the bottom by that, which leaves you with 12 √2 up top. But isn't this now just a 2 in the bottom? And isn't 12 over 2 just 6? Keeping √2 along for the ride. So again, depending on who you ask, this is a more safe answer. It makes sense to me. I prefer to rationalize because I've just been chastised for it before, but I've also seen a variety of memes kind of clowning the whole experience and saying it's not really needed. I don't want to get into a debate about it, but there you go. I hope that helps for these. Appropriate triangle for this to get these. Oh gosh, this is such a cool section. This will really help you out as you move forward. Sine of 45. I'm gonna keep referring back to this triangle for a lot of the I think 15 through 17. So this is referencing 45, 45, 90. And what's cool is that this is always referring to what this should simplify to. So if you use something like this, Sine of 45 doesn't really matter what angle you go with. But hopefully you're saying that it's one of these legs over the hypotenuse. And what can cancel? Hopefully you're saying that. Just getting you this. Then, since I've already shown it, I feel obligated to do it again and rationalize this denominator and say that this is really root 2 over 2. And isn't this also going to be the same kind of thing? It's root 2 over 2. Because you can still use this and just do the adjacent over the hypotenuse. It'll still get 1 over root 2, but then again, rationalize the denominator, RTD it. Get that? And this one's interesting because this is just 1. Because if you tan of 45, that's opposite over adjacent, and that's just x over x. And that's just 1. Capiche caposh. I'll do 18 and 19, and then I'll give you a moment to try the others. So sine of 30, recall, it's like this. Not drawing a scale. Don't chastise me for that. This is the smallest side. This is the smallest side times root 3. This is double smallest side. So sine of 30 is x over 2x. And what does that boil down to? What you're saying, just 1/2. Cosine of 30 is x root 3 over 2x. X's can cancel. 3 over 2. I'll give you a moment to try the other 4, and I'll show answers for those. Thanks for trying them. Here you go. Hope this helps. Again, I kept referring back to this triangle. Even though it's vague on what the side lengths are, you see that they just kind of wash out in the division, which is a good thing because no matter what, these are what they end up as. Pre-calc, I think it would help to just kind of memorize these or maybe notice a pattern as you go from definitely sine of 30 to sine of 45 to sine of 30 or 60. They all divide by 2, and then it's 1. Depending on who you ask, square root of 1 to see a pattern. Square root of 2, square root of 3. That little pattern may help save you a lot of time moving forward. Do you really need to see these? You've done these so many times. I don't want to guess these, but no, actually I do. It looks like this just keeps doubling every time. Not to be confused with adding 3 and then adding 6. So this just keeps multiplying by 2. So this is, out of our options, exponential. Because you keep starting at 3, you multiply by 2 x times, because this is the 0 term, which you want to get real nerdy with it. You could also say starting at 6, I multiply with 2x minus 1 times. Or starting with 12, I multiply by 2x minus 2 times. Yada, yada, yada. Got some more here. Oh, what's happening? At a quick glance, this is probably a quadratic, but let's be sure. This subtracted 6, this subtracted 2, this added 2, this added 6, this added 10. Any second differences worth noting? This is plus 4, plus 4, plus 4, plus 4. Why does that matter? Because the type of function is quadratic. And you most likely have your vertex at 2, 0. So you can throw in this. However, it looks as if there's a scale factor here. It's most likely 2. Because 3 minus 2 is 1, 1 squared. And you're trying to go to 2. So there has to be this scale factor here of 2. You can try some of the other examples if you'd like, but I trust that this is the case. And I don't think this problem's picky on what kind of equation you leave it in, if it's vertex or what, but there you go. Quadratic for sure. Exponential for sure. What is this? I like these. So starting at 8, you eventually keep taking half, I believe. 8, 4, 2, 1. Keep multiplying it by a half, x times. And go and get nerdy with this one. You could also say you start at 4, multiply it by 1/2, x minus 1 times, because this is the first term. So there's that displacement of 1 to consider. Variety of ways you could do this. I like the intercepts though. So I definitely am gonna have an x plus 4 and an x plus 2. I see this isn't just an over 1, up 1 to get a point. Looks like it's taking its time a little bit more. So it's probably 1/2. Could we check this with another point? Yeah, I mean, you could check this -1/6 just to make sure. Kind of guessing and checking, but let's double check. And if we are guessing right, this should get us to 6. So let's see if it does. 1/2 times 3 times 1. And this is why you check your work. So it's not just 1/2. It's got to be 2. Because now this would match. I don't know why I was thinking the 1/2. Well, probably thinking 1/2 from this. Maybe I was supposed to be tricky, but as you can see, my guessing and checking was pivotal. There you go. Time to go. Enjoy. Hope this was helpful. Be safe.